Hi, welcome to another video with Physics Anchor. Today we'll be solving some past questions in our JAMB, past questions under projectile. Okay, we have just two questions on the board. Let's get started. So the first question reads, an object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is dash. So they want us to calculate the maximum height. So in this case, you need to remember your formula. So the maximum height, we know that is u squared sine squared theta over 2g. So that's the formula for your maximum height. Then you can begin to list out the parameters. We know that the parameters given here, our velocity, the u is equals 80 meters per second. Your theta equals 30 degrees, and then they did not specifically mention g. We know that g is constant. That's what acceleration due to gravity, 10 meters per second square. So all the information we need have been given already, so we can apply this in the formula. So our maximum height equals u squared, which will be 80 squared sine squared 30 over 2 bracket 10, and then that will give us 80. Let's just write like 80 times 80 because I don't want the number to become so big, except you want to use calculator. So I have times sine 30 will give me half, and square here will give me squared, and that will be 2 times 10, that will be 20. That's 80 times 80 times 1 over 4 divided by 20. 4 here will give me 20. 20 here 1, 20 here 1. Okay, so what will remain is 80 over 1, and that will be 80 meters. So my maximum height will be 80 meters. So you can use your calculator if you have those functions in the calculator available to you. So let's go to our option. So that's option B, 80 meters. So what matters in this kind of question is that you need to remember your formula and you need to apply it well. Okay, so that's what really matters. It's a very straightforward question. So let's solve number 2 without wasting time. Question number 2, we have an object is projected from a height of 80 meters above the ground, okay, with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal. What is the time of flight? So you recall that your formula for time of flight is 2u sine theta over g. Okay, time of flight simply means the time that it will take the projectile to go, to the maximum height and return to the horizontal line joining the point where you actually projected it. So line of projection. So something like this. So if I'm going to sketch that diagram, we can sketch it to be like this. This is the ground, okay? So this is the height, which is what? 80 meters. I said what? 80 meters above the ground. So it is now projected. So they're asking us the time of flight. The time of flight, okay, will not be, in this case, the time that it touched the ground, but the time of flight will be the time it takes this, okay, this projectile, this object, to get to this maximum height and to return to the line of projection. So that's what you focus on. So in other words, we want to calculate the time it takes to reach the maximum height and return to the line joining the what, where it is being projected. So we have all the information. They have given us all the information that we need. Okay, we have our u. Our u is 40 meters per second. We have our theta is 30 degrees. So g, we know that one is constant, meter per second squared. So if we must calculate that, then we just put that in the formula. So we have t equals 2u, which is 40 sine 30 over 10. So that will be 80 times 0.5 over 10 times 0.5 will give us 40 over 10, and that will be 4 seconds. So let's go to our option. The correct option is what? 4 seconds. This one is just like a description, just to actually show you that what the projection was not actually done on the ground, but it was done at this particular height. But there are some questions that they will require the time it will take the projectile to reach the ground. If you hear a question like that, that the time it will take the projectile to touch the ground, that means that you will calculate the total time of flight here and the time it will take the projectile to move. You know, it will look like this. The time it will take the projectile to move to the what? Ground. But in this case, they are not asking you the time it will take the projectile to touch the ground. They are simply asking you the total time of flight. So the time of flight, from definition, is the time it will take the projectile, okay, to reach the maximum height and return to the what? To the base where it is being projected. So you have to note that. So what you need in this question is the time it will take it to reach here and this base, not the time it will take it to what? To reach the ground, because we definitely know that what? This projectile will come to the ground, but they are not asking us the time it will take to touch the ground, but the time it will take to return to the line where it is being what? Projected. So you have to note that, you know, while analyzing what? Questions under projectile. So I hope you understand what we have done in today's class. Please share this video, hit the notification bell if you have not done so, and please subscribe to this channel. Let me have your comment in the comment section for me to know how well you are coping studying with what? Physics Anchor in preparation for your JAM. Till next time, I will be having another video with you. Remain blessed and have a nice time studying for your examination. Bye for now.